Okay, so welcome to session 17. We're going to use formula to find the volumes and surface of areas of 3D shapes and cylinders. So here you should be able to calculate the volume of the surface of a cube. You should be able to calculate the volume and surface of a cuboid. You should be able to calculate the volume of the surface of a cylinder, and learners should be able to find the volume and surface of a cuboids, cubes, and cylinders. So if we look at the volumes and cubes and cuboids, finding the volume of shapes is a key application important for many commercial industry companies, including efficient packing of items shown in the pictures. Here you will revise volumes of cubes and cuboids and move on to cylinders and other shapes before looking at surface areas. So for a cube, all the sides are equal length. The sides are length length A. The volume is V equals A squared. The cube is a single length, A, B, and C. The length then is the volume equals A times B times C. And then this can also be written as V equals A, B, C. So just to see this in practice, here's an example. This shows you how that the cube, the length with side length 4 and M has the same volume as the cuboid, with some lengths 8 meters, 4 meters, and 2 meters. So for the cube, the volume is 4 meters times 4 times 4 equals 64 meters square. And for the cuboid, the volume is 8 times 4 times 2 equals 64 meters square. Both have the same volume. Examples, find other different cuboids with integers, whole numbers, lengths and sides that also has the same volume as 64 meters. And there you can see a solution on screen where it's there, the 1 times 1 times 64, 1 times 2 times that's 32. 1 times 4 times 16, 1 times 8 times 8, 1 times 2 times 32, 2 times 2 times 16. Okay, so if we look at the cylinder then, so we have the height and the radius. So again, we did the circle. We've just done that. So here, this isn't then that difficult to work out. Cylinders are really important shapes that are used extensively for containing food. For example, baked beans, soup, tins of fruit, and many other items. The cylinder is defined by the radius and the height. Its volume is given then by the formula of the ratio times the height. Example, a typical tin of baked beans has a radius of 3.7. The height is 10.8. What is the volume of the tin? So to work this out, working in centimeters, the radius is 3.7. So that's from the center out. The height is 10.8. That's there. So therefore, it's 3.7 times 3.7, because if you remember, we had to double it, times 10.8 equals 464 centimeters square to the nearest whole number. The surface area for a cube with the side lengths A, the surface area is made up of 6 squares, each with the side length A. So that's 1, 2, 3, 4, 5, 6, top, bottom, left, right, side by side. The total surface is given this way. Surface area is 6 at 2, or 6A2. The example here, what is the surface area of a cube with the 4 centimeters? So that's 4 by 4 by 4. The solution here is the area is given 6, because it's 6 sides, by 4 by 4, and that equals 96 centimeters square. The surface area of a cuboid. So a cuboid is a side length A, B, and C. There are 6 rectangles to calculate in the surface area. These will pair givens. The surfaces, so 2A times 2 times A times B plus 2 times B plus C plus 2 times C plus A. So the surface area there is 2 times surface area equals 2AB plus 2AB plus 2CA. So if we look at the surface area of the cuboid with sides of 2 centimeters, 4 centimeters, and 6 centimeters, so 2, 4, and 6. So we reduce the formula above. The surface area is 2 times 2 is 4, plus 2 times 2 is 4, because that's both sides, plus 6, plus 2 times 6 times 2. So then that's there and there. That's 16, that plus 48 centimeters, plus 44 centimeters equals 88 centimeters. Surface area of the cylinder. So surface area of the cylinder is the radius and the height made up from the top circle, the side, and the base. So that's that, all of that, and then the base. To work this out, two circles have their radius and their areas. It's a curved surface, it's spread out. So it would be a rectangle of sides, so height, and the two parameters of the circle. This gives us the total surface area of the cylinder of the surface area. So we can also write this, as you can see there. Equally, what is the surface area of the radius if it's 3.75? So think of a circle, that's there, and the height is 10.8. So again, you can see there's your solution on the screen. So aims and outcomes. By the end of this session, learners must be able to calculate the volume of the surface area. Learners should be able to calculate the volume of the surface area in cuboid. Learners could also aim to calculate the volume of the surface area in cylinders. And learners will be assessed on their ability to find the volume of surface cuboids and cylinders. So you've completed this module on volume, surface, and areas of 3D shapes. Now practice this with your activity sheets and check your knowledge and progress. And don't forget to go back in and just make sure that you've completed all the tasks in there.